Welcome, fifth graders, to our week 8 number talk. The multiplication strategy we are focused on is breaking factors into smaller factors. It's actually a great way, before you even start this video, to actually stop it and see if you can apply the strategy to each one of these problems, just to see how you would approach it before you even watch this video. It's a neat way for you to introduce yourself to just playing with numbers in your head. I know for a lot of you, when you look at 6 groups of 9, you know it's 54. That's beautiful. If maybe we want to apply the strategy, well, one of the ways we can apply the strategy is, well, we know that 2 groups of 3 is 6. We know 3 groups of 3 is 9, so 3 times 3 is 9. 9 times 3 is 27. So we have 2 groups of 27, which gives us an answer of 54. The other thing that can also be looked at is, maybe we don't break down both numbers. So maybe we break down the 6 into 2 groups of 3. Why bother breaking down the 9? Just leave it as 9. 9 times 3 is, again, 27. 27 doubled. Right? We're still getting 27. And then we still end up with an answer of 54. Now, 16 groups of 15. Again, we could break it down into where we could say, well, we know that 2 groups of 8 is 16. 3 groups of 5 is 15. So, associative property can be applied. Sorry about that, I don't know what just happened. We can say to ourselves that we have 5 times 2 is 10. 8 times 3 is 24. 24 tens is this an answer of 240. The other thing we could do, we could actually break 16 down to 4 groups of 4, and then we still have 15 as being 3 groups of 5. The difference is here, when I merge the 5 and the 4, that's going to give me a total of 20. We bring together the 4 and the 3, that gives us a value of 12. Again, we're using associative property here. So if we have 12 20s, well, double 12, that's 24. So 12 20s must be 240. We, again, come up with the same solution. Another way we can look at it is if we have 36 35s. Well, we could recognize that 2 times 18, 5 times 7. So if we do this, we have 2 times 5, again, associative properties applied, is 10, and then 18 sevens. Well, for me, 18 sevens, I do 7 times 10 is 70. 7 times 8 is 56. 70 plus 56 is 126. So then I'd be left with 1,260. Now, for some of you, like Mr. Harrison, I wouldn't have done 18 times 7. Well, good, let's not do it that way then. Let's look at it a different way. What if we were actually looking at it and we said, well, we broke down 36 into 4 times 9. We still broke 35 into 5 times 7, which is beautiful. And what if we said, well, 5 times 4 is 20. 9 times 7 is 63. So if I took 63 and I doubled it, that would still be my 126. So it'd be 1,260, because 63 not just double, it's 63 times 20. Again, what's nice about this strategy is it's one of those strategies where if you can apply it and learn it, you will continually use this in your math, on your math journey, especially when you start working with binomials and polynomials in algebra. There's other things it comes up into too, but if you can start to apply the factors into smaller factors, it is a very beneficial strategy for you moving forward, because it just allows you to work with simpler numbers. I hope you enjoyed. Thank you.